All right, you guys, welcome to this page of the notes, and here we go. This is it. This is the sort of big grand finale, the conclusion to chapter 5. We are going to work our way through an example problem, which I've given you right here, where I give you a polynomial. I ask you to find all of the zeros, both rational, irrational, and imaginary, and I've given you nothing. All you have is just the polynomial. Right? So this is really this is the culmination of all of chapter 5 coming together right here to do one of these problems where you're given a polynomial and I want you to find the zeros. Here's how you're going to do it. We are going to use the rational zero theorem to make a list of all possible rational zeros. That's what we just practiced. Now, once you have the list, you will then use synthetic substitution, which I showed you on the previous page of the notes when I showed you previous problems we've done, right? We use that synthetic division to find a factor. That's what we're going to do. Use synthetic substitution to determine which possibilities are actually zeros, all right? So we're going to go through that list and find the ones that actually work. And remember this. Recall that when doing synthetic substitution, the remainder is 0 means it's a rational zero. So that's what we're looking for. You're going to do synthetic division. You're looking for a remainder of 0. Once you find a remainder of 0, that number out of that big list is a rational zero. All right, guys, here we go. I am so excited to do these problems. I absolutely love these problems. So stick with me. They're not that complicated, just because kind of a long process. So here we go. Let's jump right into it. I first need to make my list. A naught is equal to 3. A n is equal to 1. And as promised, I've done exactly what I would say I was going to do. I'm going to try and keep that list as small as I can, right? My leading coefficient is a 1, which means my list is just going to be whatever the factors of a naught are. And 3 does not have that many factors, plus or minus 1 and plus or minus 3. So my list, a naught over a n, is equal to plus or minus 1 and plus or minus 3. All right, so as promised, I keep the list short. Now, here are all the factors that you're going to need to check. Remember, these are possible roots. Not all of them are going to be roots. I want to go through and check them to see which one is. So here's my possibilities. Here's my possibilities. I could have x minus 1, x plus 1, x minus 3, or x plus 3, right? This comes from the list, right? Plus 1, so x minus 1. Minus 1, so x plus 1. Plus 3, which would be x minus 3, and a minus 3, which would be x plus 3, right? These are my potential factors that would get me these rational zeros, right? If I set this equal to 0 and solved, I get x equals a positive 1. If I set this equal to 0 and solved, I get a negative 1, negative 1. If I set this equal to 0 and solved, I get a positive 3, right? Positive 3, negative 3, negative 3, right? These factors represent my potential zeros. Not all of them are going to be zeros. But here's what I know. My polynomial is a third-degree polynomial. Remember our general trends of polynomials, which say if you have a third-degree polynomial, an odd-degree polynomial must cross the x-axis at least once. It must cross the x-axis at least once. So what that tells me is that at least one of these, possibly 3 of them, but at least one of these has to be a 0. And we just work our way through until we find the one that works. Now guys, I have not worked these problems out previously. You are watching live math happen here. We're doing this problem together. I have no idea which one of these is going to work out. I'm just going to start at the top of the list and work my way through until I get a remainder of 0. So here we go, synthetic division. X equals -1, set it equal to 0, which means x would be equal to a +1. So that's what I'm going to do synthetic division with. The +1 goes inside the box. 3, 2, 1, 0. I'm not missing anybody. I don't need a placeholder. Just pull out the coefficients. 1, -2, -2, -3. Here we go. 1 times 1 is 1. That leaves me with a -1. Gives me a -1. That's going to be a -3. -3, I get a -6. So this one, no good. It didn't work. I didn't get a remainder of 0. Cross it off. Right? Next one. I set this equal to 0 and solve. I get a -1. So we're going to do synthetic division with a -1. Coefficients. So it would be 1, -2, -2, and -3. Bring down the 1. That's going to give me a -1 minus 3. That's going to give me a +3, which is going to give me a +1, which is going to give me a -1. I wind up with a minus. All right, so I wind up with a remainder of -4, which means that guy doesn't work either. So we cross them off, and we go to the next one. X minus 3 equals 0, which means x equals 3. So we do our synthetic division with a 3. Coefficients are 1, -2, -2, and a -3. Set it up, and here we go. 1. All right, 3 times 1 is 3. That's going to give me a +1. That's going to give me a 3. That's going to give me a +1. Holy moly. There it is. We got a remainder of 0. We have found our factor. It's this guy right here. Now remember what we can do with that. Now that I have found the factor, I can rewrite my polynomial as the factor multiplied by the reduced polynomial. So here we go. My polynomial is f of x. So I am going to rewrite this guy as f of x is equal to x minus 3, right? That was the factor that worked, x minus 3, and my reduced polynomial. My original polynomial was degree 3, which means this is going to be a second degree. So x squared plus x plus 1. All right, so these are my factors. Now I wanted you to find the 0. So you're going to set this guy equal to 0, use the 0 product property to split them up, and solve. So this is all equal to 0, which means x minus 3 is equal to 0, and x squared plus x plus 1 is equal to 0. That means x is equal to 3. That is one of them. And then here we go. All right, this is not going to factor into binomials, right? There are no two numbers. They don't exist, at least no two rational numbers that multiply to a +1 and also sum to a +1. So what I'm going to do is I have to use some other factoring technique. You could use the quadratic formula. I'm going to do completing the square. There's several options that we've looked at back in chapter 4. Please notice this is quadratic. And yes, you will need to know how to factor quadratics from back in chapter 4. I'm going to ask you how to do it. All those skills we've learned previously, just bring them along with you through the rest of the course. So here we go. Let's review how to complete the square. The first thing I need to do is move the 1 to the other side. So x squared plus x. Leave yourself a little space. -1. Now, in order to complete the square, remember, I need to add a c that is equal to b squared over 4. Right? So I'm going to add a c here, and whatever I do to one side, I have to do to the other side. What is the value of that c? Well, it's b squared over 4. And my b is a +1. 1 squared is 1. 1 divided by 4 is 1/4. So in order to complete the square, I'm going to add a 1/4 to both sides. Okay. That makes this side a perfect square trinomial. So I can factor it into two binomials. On the other side, I wind up with, let's see, -1 plus 1/4. Find a common denominator, which would be -4 over 4. -4 plus 1 would be minus 3/4. This is going to be x and x. And then remember the way that you find the two numbers that multiply to 1/4 and sum to a positive 1, you just take the square root of both of these guys. Square root of 1 is 1, square root of 4 is 2. They both have to be the same. It's a perfect square, right? These numbers have to be the same number. So it's going to be plus 1/2 and plus 1/2. And again, I got that by taking the square root of 1, which is 1, and the square root of 4, which is 2. So you multiply 1/2 times 1/2, you get 1/4. 1/2 plus 1/2 gets me a positive 1. Let me slide up a little bit further. Oh, hang on. Get this guy out of the way. There we go. Okay, I put these guys together. X plus 1/2 squared is equal to a negative 3/4. Take the square root of both sides. X plus 1/2 is equal to, okay, so I take the square root plus or minus the square root of a negative 3/4. That's where the imaginary is going to come from. So x is equal to, subtract the 1/2 to the other side, minus 1/2 plus or minus the square root of 3/4 I. And there are my other zeros. Okay, so my polynomial was a third degree polynomial, which means I should get 3 zeros. Here's one, x equals 3. My other two are the complex conjugates of this imaginary number. Minus 1/2 plus the square root of 3/4 I, and minus 1/2 minus the square root of 3/4 I. All right, guys, head on over to the next page of notes, and we'll try a couple more of these just to get lots of practice so that you get comfortable with them. So I'll meet you on the next page.